Alright guys, so welcome to another video on Do Tech Empire main stack tutorials. We are still on JavaScript. We'll be moving to the other sessions soon once we're done with basic JavaScript or once we're done with our JavaScript. So this video we are going to continue with numbers. The last video we're looking at infinity, negative infinity, positive infinity, and the like. So we saw in JavaScript division by zero is actually think not a number, and like rather infinity, while the square root of a negative number is not a number. So like for example, here is negative infinity. We saw it already, so we have here negative infinity. And now let's say for example you're writing a program which you want to determine the lowest number. You want to get the lowest, you want to compare, like you wrote a function that takes a couple of numbers and return the lowest number. So it's not really difficult, but what we do is, for example, I'm going to write that function and lowest, for example, lowest, it takes a couple of numbers. You can take any number of we are going to look at this data, and it takes any amount of numbers. So you can write something like numbers. This is how we do it in JavaScript. You can take any number, any amount of numbers, and now it stores it in an array. Numbers is going to be an array of any number. So in this case now we can write the function. We can start with the greatest number should be positive infinity, and then from there now we, if any, or let's say we say maximum equals to negative infinity, which we know a number can always be greater than negative. So we can say let max be equals to negative in infinity, or um, let's say max be equals to negative infinity. Now we can say we can now use the array to numbers dot for each. Here is functional programming, or you can use for x equals number or stuff. When I want to use number dot for each, we have a value. Let's take for each number we have a value. I'm going to teach you guys how to do this later on. But here we are using the function. We are using functional programming. I'm going to say if value is greater than max, then max is equals to value. We are going to learn how to use the if else statement soon, and that's all. Then we are going to say return max. So in this case, return max. Now we can call the function with let result be equals to um, lowest or maximum. Sorry, if it's lowest, we use maximum. So let's say maximum, and we pass 3, 4, 5, 7, 2, 2000, 4, 5, 7. So let's see, and then 49. Let's see the results of this. So we have, you see, it gave us 4, 5, 7, 3. Now, if in case it was lowest, what we do is we'll say let the lowest be equals to positive infinity, because we know every number will be less than positive infinity. So we'll say if value is less than lowest, if value is less than low, sorry, low, if value is less than low, we can say low is equals to value, and we return low. So in this case, let's see our answer. Sorry, we have an error. Max is not defined. Okay, lowest. So let's see now here. All right, so here we have 2. So as you can see, 2 is the lowest. So I just want to show you where you can, places where you can use positive infinity and negative infinity. So we have other constants we can use. For example, we have what we call the maximum positive number. If you want to get the maximum of a number, we can write number dot max positive, like max value. Let's see the maximum value possible. I think it should be something very long. Very long. See, to the power 3018, and we can see number dot mean value. So mean value. So we can see that here. All right, you see e to the negative. Now, apart from that, we can also use it instead of using positive infinity here. We can say the lowest is equals to number dot max value, and here we can call lowest with a couple of numbers 4 and 0.6 and 409 and 673 and 9. So let's see lowest from here. Let's see lowest. So you see lowest is 0.6. While we can say if we are looking for max, the required return max. All right. So now we can run it. So that's the maximum value 5e to 3.9. That's because we use, let's see, if sorry is greater than max. So you can, everybody can make mistakes. All right, so we have 448. I think that should be the greatest value we passed here. All right, yeah, so there are places where you can use that. So I just wanted to show you can look at the mean value. Now, if that's the max possible value, if number dot max possible value, if we just add 1 to it, of course we know it's going to overflow. So there we're going to have something like positive infinity. Let's see. Yes. All right. So what? Okay. Let's try to add 2, like 2 to it, and see what happens. Whether it's going to overflow. All right. Yes. Overflow to infinity. Let's take max.mean and multiply by 2. It's going to overflow to negative infinity. So mean value times 2 is going to overflow to negative infinity. So if you see something, you have negative, like it did not really overflow to negative infinity. So let's get it to, let me say, times 100. So let's see. It's still negative, can still handle what of times this. It may still work. Don't know. Wow. So okay. I know what I'm going to do. Let me add e to the 500 and see now. Yeah, so it went to infinity. So number dot mean value. All right, and what happened is because I'm even doing like this, if I just multiply it by -2, we are going to go to negative infinity, or we did not go that. So let's say e to the 4000. We should get there now. So negative infinity. All right, so there are just some examples you can use. So to go to, and of course, if you have something like 0 divided by 0, it cannot be a number, of course, because it's not infinity. So this one, we know this one is not going to be a number. Yeah, so we have not a number. And so just you should just know you can have in JavaScript we have things like negative infinity, positive infinity, and we have not a number. So you should know all that. Now let's look at some number functions that were declared in ES6. That's 2015, JavaScript 2000 version 2015. So, or added to JavaScript around 2015. It's called ES6. So let's say, for example, you have a variable called let font size. When we are going to see document object model, when you get the font size of an element, you're going to get it with pixel attached to it. For example, let's say 30 pixel. Let's say you need to multiply this font size by 30, and you want to eliminate the pixel. What are you going to do? Now we have a function called parseInt, like this. ParseInt will process the font size or whatever we pass it, font size, and everywhere it sees a non-number is going to stop. So in this case, let's see what passInt will return. So you see it returned 30. So we can now say passInt times 4. We are going to multiply passInt times 4. Then now we can add plus pixel. After all that, for example, we can say result plus pixel. In this case, we are going to add pixel to the result. It's like a string. We are going to add pixel to the result like a string. So there is it. So I just want to show you that is also possible. So we have passInt. We also have, now let me show you some stuff about passing which you should know directly. I want to show you some direct stuff. Now look at some direct stuff you can do with passing. For example, if you have hello, passing is going to return um, I think we have not a number because there was no number there, but if we have just one, we are going to get one. So but so you see, passInt stops immediately where you get the first number. In this case, you cannot pass because the first digit is not a number. You see, so we have not a number, so it ends immediately. Now even if we have 1.23, because we said passInt is going to meet this decimal point, which is not a valid integer, so it's going to stop. And for example, you see we have 1. Now what of if let me see, what of if we now want to pass a float? So we have something called pass float. Now pass float actually passes a valid float. So in this case, it's going to pick out, for example, if we had 30.7 pixel, pass float can actually pass that. But let's start by passing 1.23 hello. You're gonna see we're going to pass the float and we're going to have 1.23. Remember, it's not just passing, it's converting it to an integer. Let's see, for example, let's say let a be equals to pass int font size. Now let me show you something. Let's get the type of a. Okay, we already have a here. Let me close this. All right, let's get the type of a. Let's print some things out here first. Let's comment this out. When you comment something, the browser actually ignores it. So it's not JavaScript that will not execute or process it or interpret it or whatever. So we can say type of font size. So in this case, you see string. Oh, sorry, we did not say console.log. Console or console.log. So type of font size. So let's see what it gives us. All right, we have string. Take notes. So but if we write now type of a, you see it actually converted it to an integer, not just to a number. Sorry, you see number. So it actually converted it to a number. Let's use our print function so that we're going to see it well. Remember, we declared the print function up here that inserts it into an h2 element. So here we have number, and so in this case, let's pass float. When we pass float, for example, it actually takes, in this case, so let's see the value here first. Let's see the value here. Let's print out a and see what a is. So as you can see, a is 30. It extracted 30 from here because 30 is the first valid integer. Remember, integer don't have the decimal points, so that was the first valid integer. So the next thing we can try now, if you use pass float, for example, pass float is going to convert that font size to 30.7 because decimal point is a valid, is a part of a floating point number. So in that case, we're going to see 30.7. It means it has converted it to a float. Now those are the first two you're going to use. Now you can check if something is a number or not. For example, if you have a function that actually let's say takes a score, let's say it gets result and it passes score. So I'm just going to write the head of the function, and let's say function print score, and it takes a score, and you want to make sure that score is a number. It displays something like print. It uses our function, says your score is let's say plus score. Now what if you only want to print score? Let's say you want to add 5% to the score. Your score is score, let's say plus 5 all over 100 times score. Now let's say you want to add print, let's say print let's say print bonus. That's the name of the function, because it actually add a bonus of 5% of the score to the score. So your score is this. All right, now let's call that function print bonus. We pass it, let's say 40. Now let's see what it does. It actually, your score is 40 plus 5%, 5 over 100 times score, 5% of score. So it says score, let's do this, plus, yes, so let's do this, or let's just create a variable here called let new score equals to score plus 5 over 100 times score. So we'll say your score is new score, yeah, new score, yeah. So let's see the output. Yeah, so your score is 42. Now let's give it 86. So in case we give it 86, we are going to see 90.3. All right, now let's see something. Now let's say we pass, instead of passing a score, we mistakenly pass a string like this. Let's see what's going to happen. Your score is 8, or we have 86 4. So what it did is it just added the extra to the score. It took it as concatenation. So you see it's wrong because we added 4.3 and stuff like that. So it's wrong because we passed a string. What if we did not even pass a number? We passed hello. So hello none. So you try to add and you try to do a calculation and that did not work. So we have hello not a number. Now what you can want to do is you can want to check first if it's a number that has been passed. So we can say if we are going to learn all this if else expression soon. If not is none, if it's not a number, what we do is that's why this not is a negation. Score print, you can say print you must supply a number. So we can say print you must supply a number, and in that case we can say we can go out and say we can return will return the function, return from the function, and this part is not going to be executed. So now if we pass not a number to it, your score will, all right, let's see. All right, so okay, if it's none, it's not a number, not if it's not. All right, so this will work now. You must supply a number. So is none is checks if any variable is a number. So for example, is none. Let's try it out here with our stuff here. So let's check is none. Let's check is none. Is this a number? 200 is going to tell us. Is this a number? Tell us 200. False. So you saw this one returned false. So is none actually returns a boolean that it can return true or false. So is 200 not a number? It is. So it returns false. We can say not is none will give us the opposite. So true means this is a number. So let's try what of this. Let's see whether it is now process the string. True. So it's now actually checks if it's a number even when it's in a string. So for example, if we come and add d here, it's now is going to tell us false. Yeah, so you should see that it's now takes strings into consideration too. It checks if the string is a valid number, even though it was not a number, but inside the string you realize it can easily be converted to a number. So let's try to print out. Let's say result equals to 200 plus no times 5. Now you see what happened. Now when you use times for strings, JavaScript first goes into check if that string can be converted to a number first. If it can be converted to a number, then JavaScript simply converts them to a number and then multiplies them. But if one of them cannot be converted to a number, then an error will be displayed. So not a number. So that's not a number. So let's say, for example, let's see how it works with plus. With plus, it works a bit differently. You see, 2005, what it does is that it tries to concatenate, it doesn't try to convert. Since concatenation is a valid operation with strings, you just add them. That's why you have 2005. So if you want to do this, you can easily say pass int, but there's no need, but you can just say pass int like this and pass int like this. Let's say this was supplied from a database in the form of a string and you want to convert it. So if you're not sure if something is a number, is a string or not, but you want to convert it to a number, you can use pass int easily, and now we have the right value, 205. All right, so there are some examples we have seen. Is now we can see it's finite. Now is finite actually checks if a number is finite or not. Now let's see result. It's finite. It's 5 finite, of course. Is finite. It's checking whether a number is infinity or not infinity. It's finite. 30, of course. 30 is finite, so it's going to return true. So true. What of is finite? 0. 0 divided by 0. Is it finite? I don't think. I think it should give us false. What of the square root of -1? Is that a finite number? No, no. Math.sq square root of -1 should give us, is finite, will give us no. So we see nope, it's not finite. So even what of max.maxint max number, sorry, number dot max value, is it finite? Yes, of course, because that's an actual value. Yeah, so it's finite just checks if a number is infinity or not. So you can also check if a number is an integer. For example, you don't want people to enter decimal point in your function. You can, maybe you're writing a program that takes only integers, which means decimal point should not be above. Like if you're working with the age, what is your age, or let's say, or you can say display age, display age. In this case, you want to check if the user age is not a number. You say wrong age, for example. If you can say if let's comment this out. You can check if not is number is integer, because age must be an integer. Remember, is integer, is integer. If not is integer age, you can say print, you must supply a number, return, or you can print you are qualified, you are qualified, something like that. So let's see what happened if we say console. No, we want to call the function now. We can say display age. Now let's see, let's pass it 30 and see what it says. Oh, on call reference, its integer is not defined. Oh, it looked like this Firefox does not support its integer. Or all right, so let's see. Okay, is number is a number, is an object of number dot, I think this is okay. All right, so number dot is integer. Let's check now. So all right, you are qualified. What of if we pass 30? I think you should process a string to know whether it's still valid, maybe or not. All right, so it doesn't even process a string, so it checks if it's integer. This is a string. What if you supply, let's say 30.2, you know that's not a valid age. So you see it says you must supply a number. It only takes valid integer. Yeah, so for example, valid integers, that stuff without decimal point. All right, so you have, okay, it save integer. It checks whether the integer, there's another value, there's another option we have which is called number dot is save integer. We are not going to look at that. That's just checked if an integer is between -2 to the power 53 and 2 to the power 53. So you should understand that. So let's say, let me just do it. Number dot is save integer. This one, let's say if we pass it 2000, it's going to work, of course. But let's say if we let's see this. Yeah, that's true. But let's say we pass it something like negative, you know, it should not be a very small number. So let's say if we pass it -2e, -2e to the 53, e to the 53. Let's see if it's a safe integer. False, you see, because the minimum safe integer is -3e to the 53. That's the minimum safe integer. So it's just to check if the value is too big or the value is too small. You understand? So let's use e to the 52 and see. All right, we still have false. Okay, let's see. Okay, 2e to the 50. This one. All right. Okay, 2. Let's say, okay, it's 2 to the power 53. So let's say 2 to the power 53. 53 should be a safe integer. 2 to the power 52. All right, 2 to the power, it should be less than 2 to the power 53. So it starts from -2 to the power 53 to +2 to the power 53. So those are safe integers, just to check if an integer is too big. So let me actually display this. Let me print, let us print 2 to the power 53 and see. Print. Let's see how big it is. 2 to the power 53, 2 to the power 53. Let's see how big it is. So this is not a safe integer according to JavaScript. It's too big. It's too big. So just understand that's once you reach 2 to the power 53 is no longer a safe integer, or -2 to the power 53 is no longer a safe integer. So I just want you to know that. What is it? -2 to the xy 53. All right. Let's see. Okay, -2 to the power 53. We have it -2 to the power 53. Okay, so all right, so there we have it. So is negative. All right, so those are positive stuff. So now the next thing we are going to look at is some other constants in the number. So we can check the minimum safe integer, mean safe integer. We can print it out. Let's check the value. This is the mean safe integer. I told you 2 to the negative 2 to the power 53, and we can have max safe integer. Max safe integer. See, yeah. And if you check 2 to the power, if you print out 2 to the power 53, you see that that's it. 2 to the power 53. Check it out. All right, you just see +1. So 2 to the power 53 minus 1 is going to give you the, which you see. Yeah, so that's the same as the max safe integer. You can see. Yeah, so I just wanted you to see that. All right, the next one we're going to see, we have seen mean save, and if you want to know the smallest difference that can exist between two numbers in JavaScript, we call that epsilon. So we can say number dot epsilon. Let's see the smallest difference that can exist between two numbers. Very small, very small. I mean, JavaScript has this amount of precision to detect differences between two numbers. This amount of precision. So that's really a very good precision. So those are the smallest difference between two numbers. That's the smallest difference between two numbers. So in JavaScript, you can also have this. For example, we can have, let's say, we can have negative 0. Negative 0 is a valid Java, but it's the same as 0. So let's check. Let's use equal. Let's check. Is negative 0 equal to 0? Yes, in JavaScript, negative 0 and 0 are the same. True. So we are going to check that. We are going to see this expression condition comparison operators soon. That less than, less greater than, less than or equals to, and this stuff. You can see this is double. You can this statement either can either return true or false. So we are going to look at that. So let's move to something else. Now let's look at a problem which usually happens when you're working with very small numbers. You might never face that problem, but if you're working with very small numbers like the weight of air or gases or stuff, you may encounter problems like let's note some few things. For example, let's see, let num or div1 be equals to, let's look at the difference between 0.3 minus 0.2. We know that this should be 0.1. According to us, this should be 0.1. And let's say let div2 be equals to, let's say 0.2 minus 0.1. Now look at this. Now let's print this out. Let's actually print some of this out. Let's keep this print, or let's just use this print. Or let me close out. All right, so let's just print this out. Let's print this two out. Remember, print is a function which we declared. It's not by default in JavaScript. As you can see, print, usually if you use print, the browser will try to print a document. So but we declared our own function here, print, so we are using it here. So let's print div2 div2 div2. You can see let's see. So you see there's a difference. So JavaScript have some rounding issues because JavaScript uses what is known as binary floating point numbers. It means internally in memory or in hardware, it represents binary that's floating point numbers as binary numbers. So all programming languages that do that have an issue with rounding of numbers. So you can see this is not the same, but you expect it to be the same because of course 0.3 minus 0.2 is 0.1 and 0.2 minus 0.1 is 0.1. You can argue with the fact that let's div3 equals to 0.8 minus 0.7. You also want this to give you 0.1 div3. You also want this to give you 0.1, but you can see it also rounds up to something a bit greater than 0.1. So you see JavaScript generally has some rounding issues, so you are not very sure of all this rounding, and you can see these are all different from each other. So I just wanted to show you that you need to take note of that. When you're working with very small numbers, you should know JavaScript may not give you the exact number. For example, you can think this is equal to this, but for example, if you write console.log, you see if you write div1 equal to div2, you see it's going to write false. Okay, on the console, sorry, you see we have false here. That's because div1, I wanted to use print, so let me just use print so that we can see it on the browser. Print, remember, print is a function we declared, not by default on browser. So we have false, so we can see, but by all indication from our mathematics, we know 0.3 minus 0.1 should give us 0.1. and give us 0.1. 0.2 minus 0.1 should give us also 0.7 minus 0.8 minus 0.7 should give us 0.1. But you see, all of them gives us different value. So JavaScript normally have some rounding issues because it uses binary numbers to represent floating point numbers in memory. So of course there are some approximation issues with that internally. Alright, so let's move forward. So I've shown you some differences, some problems you're going to encounter when it comes to comparing small differences between floating point numbers. So just take note of that if you're writing very sensitive mathematical applications. And I guess if you check online, you're going to see solutions that can help you handle that. So let's look at one other stuff. In JavaScript 2020, we have a new feature which is known as BigInt. So it has been implemented by various browsers like Chrome, Firefox, Edge, and even Node. And there's also, I believe by now, Safari should also have implemented it. So the type was added to JavaScript so that JavaScript can be able to handle 64-bit integers, because right now I think it's 32-bit. But right now the new implementation allows JavaScript. You see, when integers become too big, JavaScript represents them as infinity. For example, if we say console.log and we say 3.6, or let's just say 3 integers, so 3 to the power um, let's not be too big. Let's see what it's going to give us. So infinity. All right, so I just want to show you. Let's print. So you see, this is normally a number, but we can't get it because it's so big, and JavaScript just tells us infinity. So let's reduce it a little bit and print it out and see whether we're going to still get infinity. We see how. So you see, JavaScript is not able to really represent very big integers. You see, this is a very big number. So let's add like 3 in front. You see, so we have infinity. So let's say 1, for example. Oh, we have infinity. All right, so but what of if you want to print it now? Adding n to a number, if you say if you add n to a number, for example, let's say 3n raised to the power 1n. Let's see whether it's still going to give us infinity. All right, you see now, you see this number can be represented. Look how big it is. Look how big it is. Look how big it is. So JavaScript allows us to be able to, so just printing, you can print 3n. You can print 3n alone. It will be 3. So it's 3. But adding n to a number allows it to tell JavaScript it's a big int. So you can, if you want to represent very big variables, just add n to them. So let's try 2 raised to the power. So we're trying to tell JavaScript is a big int. So you see the number is so big, that's why it could not be represented. You see, very long. You may never need to work with this kind of big numbers, but I just wanted to know they exist. Alright, so in the next video we are going to look at other examples on using BigInt, and we are going to look at the JavaScript date object. Alright, so have a nice time, and see you in the next video. Thank you.